So I wanted to give you a brief introduction to your polynomial curve fitting assignment in this module. And let's start off by just going ahead and first of all, let's load in that data. So we got noisy poly. And if we go ahead and plot it out, the star is just one kind of symbol. You can do help plot and see all sorts of other symbol options. But if we plot this thing out, we see, oh, yeah, okay, this kind of looks like a third order curve. Obviously, it's got noise on it, but it kind of looks like a third order curve. Now, I think I've mentioned before that the actual mechanics of fitting the curve is straightforward, and that's obviously something we're doing here in this exercise. But the part of the art and science of engineering where the expertise and experience and intuition comes in is figuring out, well, what model am I supposed to fit? This one was fairly obvious. You take a look at it and say, well, this looks like a third order curve. But who knows? I mean, you could look at the data over longer intervals of the x-axis, and then it'd be surprised to find out, no, this was actually just a hiccup. So again, it takes your engineering judgment in order to know what kind of model you're supposed to be applying in the first place. But anyway, for this particular example, it is indeed a third order polynomial. And if I go ahead and run my solution, what you will see is by implementing the techniques that we've talked about, you end up with a pretty nice curve fit there. And as a matter of fact, you even get to see what the values of the estimated beta vector are as well. Now, you of course are going to reproduce this in your homework, but you get an idea of what you're shooting for. Now, one last thing that I want to mention before we close this up is to take a look. You may recall that when we were creating our best fitting curve, we were doing things like y is equal to beta, the first beta times x raised to the 0th power, then let's see, plus beta, the next one times x raised to the first power, blah, 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 all that kind of stuff. Well, you might be saying to yourself, there's got to be an easier way. And in fact, there is. So if we take a look at the equations we were looking at earlier, we say, well, okay, so this is the general linear model. Well, what do we have after we've done the least squares solution? We already have h, and we have the least squares estimate of beta, right? And we don't know exactly what beta is, but we have our least squares estimate of it. So we have h, we have beta. So how do you think we're going to come up with the best fitting straight line? Yeah, exactly. Just take h, multiply it by the beta that you get out of your estimate, multiply those two together, and voila, that gives you your best fitting curve. So when you're doing your homework and you've created the h, you've estimated the beta, then creating the best fitting curve should be very straightforward to you.